When you're talking about ECG, how do you actually record it? We talked about interpretation and what they mean with the help of a 12 lead process. Now, of these 12 leads, we have 6 chest leads, and you have 12 limb leads. 6 of them are bipolar, 6 are unipolar, meaning both the electrodes are placed on the body and have a part to play. Whatever. In this, one of them is indifferent, so it's unipolar. Right? So let's talk about this in more detail. So, like, if you're talking about the bipolar limb leads, aka the standard limb leads, now they can use either terms, so they're the standard limb leads. They're bipolar because both of the electrodes are active. Both are registering something, and the actual recording or the result is because of sort of like a result of both the electrodes recordings, both active. So how many? I've said that there are 3 limb leads. Of them, 6 limb leads, 3 are bipolar. So how do you place them? I'm not very good at drawing people. Anyways, this is a guy or a girl, whatever, and right. Anyways, this is a person's right, this is a person's left. Now, this is kind of useless in terms of ECG. Let's talk about, we have 6 leads, each of them has a positive and a negative. So the right arm gets 2 electrodes from 2 leads, different leads, and I guess it's unfortunate, but it gets the negative electrode of each of them. Sad, right? The left leg, on the other hand, is very lucky. It gets the positive electrode from both of the 2 leads, and the left arm has a positive and a negative. So we're talking about 3 bipolar limb leads. So the first limb lead is between the right arm and the left arm, and it's known as lead 1. Right? The other one is from the right arm to the left leg, and that's basically lead 2. And then the last one is between the left arm and the left leg, and that is lead 3. It's kind of inverted, it's kind of like this. So these are important, and all of them are important, and they each have their own recording, which is a bit different because they're recording from different points. Now, we generally make this reference line, and the reference line points towards the left of the body, and we use this reference line to give an axis to each of the leads. So each of the leads has an axis, and how do we give them this axis? Is it arbitrarily given? It's given according to this reference standard line. So because lead 1 is horizontal and is basically also pointing towards the left because it's negative to positive, lead 1 has an axis of 0 degrees. Lead 2, on the other hand, because it is kind of like this, negative to positive, it gets an axis of plus 60, right? Lead 3 is kind of like pointing like this, right? So if you draw it like this, it's kind of going like this. So it has an axis of 120 degree, right? And this will be important. Now if flow is from negative to positive, you get a positive deflection. If it's from positive to negative, you get a negative deflection. Easy. And let's talk about the other leads now. Basically, when we're talking about these bipolar limb leads, we use something known as Einthoven's triangle because of the way the stuff is positioned. It kind of makes a triangle with an apex, right? Now, when we're talking about augmented limb leads, they have some source of additional power coming to them, but that does not distort their recording. AVR is when one of the electrodes is indifferent, and it's sort of connected to the indifferent part is connected to two limbs, and the positive part is located to just one of the limbs. And when the limb, and these are connected one at a time. No, not one at a time, my apologies. Anyways, so for example, if it's connected to the right arm, it's kind of like this. So this shows that it is connecting to both the left arm and the left leg. So one wonders basically what is the axis of this. You might very well imagine it's kind of like this. It's almost 210. AVR has an axis of 210 degrees. Whereas if it's AVL, it's pointing over here, it has to be coming from over here because this is joining two limbs. So this is almost 90 degrees AVL. AVF on the other hand, because it's like, this is F, so it's kind of, my apologies, it's kind of wrong. It's AVR, it needs to be connected. Where does it need to be connected? It needs to be connected, the positive electrode needs to be connected to the right arm. The right arm is over here, and the indifferent one has to be connected to the other two. And because this is the one that is connecting the other two, if we connect it to this, it's kind of like this. And this is AVR, so it's 210. That is the axis. AVL means positive needs to be with the left arm, which is over here, and the indifferent needs to be connected to two other limbs, and this is the one that is connecting to other limbs, so we connect it to this. This is minus 30 because this is horizontal and it's like this, so 270 degree or minus 30. Then we have AVF, which is basically it's pointing over here, and this is 90 degrees. Now if we finally talk about the chest plates, again, one active, V1, V2, V3, V4, V5, V6. So one is basically earth in a matter of speaking, the other is directly on the chest. Basically it's fourth left intercostal, fourth right intercostal. This is fifth right intercostal. This is a sort of like in between, and this is fifth intercostal, mid axillary line, anterior axillary line, and this is mid axillary line. These are not that difficult, so we'll come back with vector analysis.